Alright, we are doing page 271, number 64. The question asks, we have a compact car going 100 kilometers per hour. What height would we have to drop it from in order to reach that same speed? Okay, this one's going to be a few steps, and I'm going to use a different problem-solving strategy here that maybe you can employ to cut some steps out of your solutions. But first, we need to convert, and I will do that. The reason we have to convert is because we have to have meters per second when dealing with accelerations and velocities to make sure all of our units agree. So I'm going to convert to meters, and I'm going to convert to seconds. And I think I've went through this earlier on one of the videos. So if I do all that math, and you know, I should just cancel out just to show you what's canceling. Oh, and to proofread so that I don't miss my labels. There we go. Now you can see where the numbers and labels come from, and the answer is 27.78 meters per second. That's the speed when we convert. Now, I think by this time in the class, I hope you understand that if we were going to convert something from kinetic to potential, because it's joules and joules, everything is the same. So when something falls and gains speed, what we're really saying is that if we take 1/2 times the mass of the object times the velocity squared, that will equal the mass of the object times 9.8 times the distance it falls, and those are equal. You gain altitude, you convert that to speed when you fall, and so on. Going back to pink now, let's put in some numbers that we know. 1/2 times mass times 27.78 squared equals the mass times 9.8 times distance. And some of you might be asking, well, we didn't fill in a whole heck of a lot, but we also discovered something. That mass repeats itself as a multiplier on both sides of the equation. So if the compact car's mass doesn't change, it will cancel on both sides of the equation. So mass cancels on both sides. Now we can really break this thing down and simplify it to 300. Come on, pen. 385.86 equals 9.8D, and we're not much above a Algebra 1 problem now, and if it's even an Algebra 1 problem. Divide both sides by 9.8, 9.8 cancels, we get D, and sorry I ran out of room there at the bottom, so I'm going to put it right over here. The D in this problem equals 39.37 meters. That is how you would solve this problem, especially when you don't know the mass of the object. If you like this one, the previous problem, number 61, has how to figure out speed when something's dropped and you don't know the mass of the object. Okay.